Hi guys, welcome back to my channel. So today quote is the way to get started is to quit talking and begin doing. So let's just doing. Yeah. So far we have talking about the streams. What are the streams? Why they are immutable? Yeah. So today basically we are talking about the methods, as I have mentioned earlier in the previous video, that we have to go deep dive into each methods and learn behind the scenes or under the hood how they are working. So let's start it. Before doing that, I would like to you know there are three streams, then I've put answer variable. So basically I'm trying to reduce the code or make it clean. So and our code is just repeating many times, so there's principles of clean coding is do not repeat yourself, dry principle. So I'm just violating it, so I'm just correct it. Let me declare a variable answer. So the first stream is basically I'm just trying to show you the different way to write stream. Here you declare the one stream, there put dot, then the filter for the even numbers, and then you set the map for, let's say, just twice. I'm not changing the conditions which I used earlier because I know the previous result is 24, so we got to know that we are on correct path or not. And here reduce, you just use some black box which gives the sum of the stream. Yeah. So I'm just printing result here this time. Okay, just compile first, then run. Yeah, 24. So our clean code works properly. So just let me get rid of this. Yeah. Okay. Just remove the stream. Yeah, perfect. So now we go deep dive into each method. So start with filter. Yeah. Here you seeing that it is using some predicate object. Okay. And inside predicate there is a method called test. Okay, so just do it. Let's see what it is. Let's say I'm using predicate. You're seeing predicate is util dot function dot predicate. Okay, then mention class is integer p, let's say, and we are creating new predicate object. Okay, and just implementing the method. Let me remove this. Yeah, basically here it's showing that whether it is true or false. So it is boolean. So let me just try that condition here. If my t is even, then just return true, and else just return false. Simple. And I am just remove this filter condition and just write in the object of predicate. And now just compile it and run. It will be perfectly fine. Okay, as you've seen also, let me just showing it. This is a functional interface, and whenever any class is using functional interface, you can write lambda expression, make it as a thumb rule, because it will look or make your code cleaner, so someone other developer just seeing it understand, oh, it looks clean, fine, I understand it, that's it. Okay, so first I just make it shorter. I'm just done this thing, yeah, particularly perfect. And this is already know, I'm just not doing, and now I'm converting it into the lambda expression, and we are an expert in this thing. And we're not mentioning it here, and you know, when just this is perfectly fine, and you can just try it, just run. Whenever you're confused, just check the output. When you get the correct output, it means you're on correct path, so just go ahead. Yeah, there's no doubt, just do it. So let me just do this also, because whenever there is one statement, you don't need, yeah. And when you replace this here, let me remove the predicate object. You don't need further predicate object, so remove here from, and just check it. Pretty cool, yeah. You just quickly understand and clearly how filter work. It uses under the predicate object, which uses an apply or test method. Sorry, test method. Map use apply. I am done some cheating and I'm already know it about it. Yeah, I get red-handed caught. Okay, so now let's start with the second method, map. Just open it, and oh, it uses function object. We're doing the things, so we got to understand how it is working, and we itself familiar with how to write lambda expression and how to read code from others developers. So you know, it showing that it is using some function okay object. So just write it, and there is no laziness in just writing it. To just learn it, to become good or great software engineer or whatever Java developer. Okay, so function, yeah, actually just missed it. Here you seeing there is two t and r, which is the input and the output. Here you seeing the function argument, and that is output result class. So just mentioning it here, integer the output class, yeah. And just implemented methods, because here you in function you have to implement the apply, which means what to apply to your current numbers or the current stream of numbers, whether you're doubling it, tripling it, 4 times, divided by 2, multiply thrice, it all depends on you. So I'm just returning it, multiply with 2, and I am just replacing it with my function object, and just check it whether it is working fine or not. Yeah, absolutely fine. And it is also, first check it, don't be overconfident. Yeah, fine. Function interface. Second is, whenever you see function interface, the second thing which click in your mind is just use the lambda expression to make it look cleaner or cooler. So just remove from here to here and just use some arrow. Oops. Just remove this, put it here, and it is one liner, so just remove this also. This brackets, return. don't need to mention the class. Yeah, let's check it again. If we have not missed anything, then we got a result 24. Yeah, absolutely. So let's just, yeah, I think it's fine. So remove this. Don't necessarily put objects, just write clean coding. Yeah. Okay, now the third method is reduce. Just open it. Yeah, here you seeing it is your identity, and then some binary operator object. Okay, then open the binary operator. It's something using some by function. In by function, simply use the apply. Okay, just as previous apply, we have to just perform some operation. Okay, so let me just not confusing you. I'm just basically what the reduce function is doing. Our stream of number is, let's say these are our streams of numbers, and initially as have you seen here, I input 0. So what this denote is basically initialize. You can say it is our initial sum, which is I am mentioning 0. Whatever you mention it will taken it from here. And there are two things I mentioned in my code, the C and E, which means let me just put it here, make it say white, C and E. Basically C, yeah, C basically implements the carry, and E implements or denotes the element. So initially these two combine, this with the initial sum, this with initial sum goes, and it will return 1. Now okay, let me declare it separate. Yeah, now the E is element, and the carry which going toward next is this. So in the next, this is carry, this is element, then our output is 3. Now our element is this and the carry is this. Basically I'm just trying to explain you the by function which under the hood you apply, and this is how apply works. For my logic currently, which we have just adding two numbers, it may be you can subtract two numbers, or depend on you how you apply you or how you operate on the streams. So in the same way it is 3 3, then it gives you the results of 6. Yeah, it gives the result of let me just try it separate. Now it gives the result 6, then this will be considered as carry, and this will be considered as element, and so on, go for. So this is how the by function or the reduce will work. And let me further compile, and yeah, 24, that's perfectly fine. So yeah, this is basically the extended video of the stream API. I'm going in the previous video, I'm just operating the operations so that you know what operation do what things, and in this video basically I'm trying to teach you about the in-depth implementation that filter uses some predicate the map using some which one function object, and then reduce using some binary operator which under the hood using some by function. So yeah, that's it for this video. Thank you guys, bye bye.